In this video, we're going to identify congruent parts of congruent triangles and use what's called Cpctc to solve problems. So first we're going to go over what congruence means with two figures. So figures 1, 2, and 3 are actually congruent. They're exactly the same shape and same size. So all of the measurements and dimensions of these figures would be the same. In these figures, 4 and 5 have the same shape, but they're not the same size. We would say that these would be similar figures. 5 and 6 and 4 and 6 aren't even quite the same shape, but they are about the same size for 5 and 6. So we wouldn't say that those are congruent figures. All of their dimensions would not be the same. So we have this definition of congruent polygons. Two polygons are congruent if and only if their corresponding parts are congruent. Notice that if and only if part. That means if we have polygons congruent, all of their parts that match up will be congruent. So if angle A is congruent to angle H, that's one part. B is congruent to J, that's two parts, two angles. Angle C would be congruent to angle K. So we have all three sets of angles that are congruent. AB is congruent to segment HJ. BC and JK are congruent, and AC and HK are congruent segments. We have all of our corresponding segments are congruent as well. So all of our sets of sides, all of our sets of angles are congruent. So we could write the congruence statement that triangle ABC is congruent to triangle HJK. Notice how those parts match up when we write that congruence statement. That A matches with H because angle A was congruent to angle H. B matches with J because angle B was congruent to angle J. And C was congruent to angle K. So they match up. Another way to write that statement would be triangle BCA congruent to triangle JKH. Notice again, the first matches with the first, second with second, third with third. A way to not write that statement would be to mix them up. Notice that A does match with H, but the second letter B doesn't match with the second letter here. And so that would not be a valid congruence statement for that example. So we have this example here for the two polygons QRSP and DEFG. We want to show the polygons are congruent by identifying all of the corresponding parts that are congruent and then writing a congruent statement. So the angles that are congruent, we would see the number of curves in those angles. Angle P and angle G have one curve, so those are congruent. Q has two curves. The angle that has two curves in the other polygon is F. R matches with E, and S matches with D. And so those are my congruent angles. We have all of our sets of angles that are congruent. We have all of our sets of sides that are congruent. GF has one dash and PQ has one dash, so those match up. They have the same number of congruent dashes. PS matches with DG. EF matches with QR, and DE matches with SR. So we can see all of those statements here that show those pieces are congruent. Now that we've shown all of our pieces are congruent, we can say the wholes are congruent. So once we've matched up all the pieces, we can say the whole figures are congruent figures. So because all corresponding parts of the polygons are congruent, we can say polygon PQRS matches or is congruent to polygon GFED. And again, notice that P matches with G, Q matches with F, R with E, and S with D. So that congruence statement is really important to make sure we match up the right parts. Now, the phrase if and only if in that congruent polygon definition means that both the conditional and its converse are true. So if two polygons are congruent, then we know their parts are also congruent. For triangles, we have what's called corresponding parts of congruent triangles are congruent. Or the acronym that stands for that statement, so we don't have to write that out every time, is Cpctc. So whenever you see Cpctc, it stands for corresponding parts of congruent triangles are congruent. So in these two triangles here, we have that triangle ABC is congruent to triangle DFE. That tells me exactly what parts match up here, that angle A is going to match with angle D, or side AB is going to match with side DF, because those are the first two letters in this statement and those are the first two letters of this statement. So we know in this picture how we can solve for X and Y. We know that angle F and angle B will be congruent because those parts, according to our statements, match up because of corresponding parts of congruent triangles being congruent. Then we can set the measures equal. So we can substitute in the expressions for those angles and then solve for y. So we can find y is equal to 13. And of course we could plug it back in and find that angle F is 99 degrees. For X, we notice that that's part of segment EF. The corresponding part in the other triangle is side BC. So FE is congruent to BC because corresponding parts in congruent triangles are congruent. Then we can say the measures are equal because of the definition of congruence. Now we can substitute the expressions that are represented by those in for FE and BC. But previously we solved for y, so I can also substitute our value for y into that expression here. So now I have 2 times 13 plus x equals 38.4. So simplify that a little bit, which of course is actually substitution there. And then subtract 26, and we get x is 12.4. Right, this problem down here I want you guys to do, I want you to solve for x and y in this example, knowing that triangle RSV is congruent to triangle TVS. Okay, we have another theorem that we want to introduce. This is called the third angles theorem. So if we already know two angles in this triangle, we could find the third. But if we know those two angles are congruent to two other angles in another triangle, we automatically know those third angles have to be congruent. And that's what this theorem says. If two angles in the triangles are congruent, then we know the third angles are also congruent. So this proof here gives us some given information, which is marked in the picture, that DE is congruent to GE. DE is here, EG is here. So we've marked that congruent segments. DF is congruent to GF. DF has 2 dashes. GF has 2 dashes. Angle D is congruent to angle G. D and G are congruent. And then it tells us angle DFE, which is this angle here, is congruent to GFE, which is this angle here. So we've marked all of those things in our picture. So right now I have 2 sets of angles and 2 sets of sides that are congruent. Let's see if we can prove that those triangles are congruent. So we'll always start off with some given information. So we'll start off with 2 sets of sides that are congruent. Notice that third side is shared by both triangles. So it's actually going to be congruent to itself. When something is congruent to itself, it's the reflexive property of congruence that shows that. Now we all have all 3 sets of sides that are congruent. Now let's see if we can do the angles. So we were already given 2 sets of angles are congruent. That was given to us. Now the third set of angles will be congruent because of that third angle's theorem. If we know two sets were congruent, that third set of angles will be congruent. So that third set of angles is congruent because of the third angle's theorem. Well, now we have all three sets of sides that are congruent and all three sets of angles that are congruent. So all of our parts for those corresponding pieces are congruent. So now we can say the two triangles are congruent because of the definition of congruent polygons. And that definition said if we can prove all of the parts are congruent, then the polygons are congruent. All right, here's a two-column proof I want you guys to try. I want you to prove that triangle JLK is congruent to triangle PLM. It's actually very similar to the last example.